written as a fraction. That's really what it means. And the irrational can't be written as a fraction. That's nice, right? We're going to look at those definitions. We're going to look at examples of those. We're going to look at what happens if you find the sum of two rational numbers. And is it rational? Explain why that is. And the product of two rationals is rational. And we're also going to be asking you to explain why the sum of a rational and irrational is irrational. And why, if we find the product of non-zero, and that's really important, right? Non-zero rational numbers. And we're going to be looking at that with irrational numbers, and is it rational? So we're going to be able to explain those different things. Like give a reason or give an example is what you're going to be looking for. So kinds of numbers. We've talked about rational and irrational. Anyone know any other types of numbers you could give? Kind of specific names. You could even look down below, right? Look at that. Look at all those different kinds of numbers, okay? So that is what we're going to be looking at. So you see that kind of like tree diagram going down there? So when we think about kinds of numbers and where numbers fit in, it's kind of a hierarchy is how you might want to think about this. So when we are talking about real numbers, now, I am kind of I will write over these boxes sometimes, but sometimes I will move them. I just want you to know, if you can't read my writing, you need to let me know, and then I will definitely move the box, but sometimes I prefer to write it, so I'm doing it kind of at the same time as you are. But if we are starting off, real numbers, when we take a look at those, any value on the number line. So every number that's on the number line is considered real. That means you're going to have fractions, decimals, negatives. You're going to have the square root of 2, which is irrational, by the way. You're going to have pi. You're going to have negative 3.75, right? Decimals that end in repeat. Other category is, last year you might have talked about this, is the imaginary. You might not have talked about it too much, but when you're finding square roots, you can never find the square root of a negative number. So numbers that are not real, that's pretty general, right? Makes sense. Real numbers, not real, is imaginary. And this would be, an example would be like the square root of a negative 1. That is considered to be an imaginary number. Okay? Square root of any negative. This is negative underneath because there's not two numbers that are the same number that can multiply to give you negative 1 or give you negative 4, right? Rational numbers. What are we talking about for rational? Rational, any number that can be written as a fraction. And notice I put with that, it includes all decimals that end or repeat. So when you're thinking rational, is that better? When you're thinking rational numbers, fraction, all decimals that end or repeat. Now sometimes your calculator doesn't show all the numbers, right? When it's a terminating decimal, it might have a bunch of them. And when we think about this, every rational number is a real number. Okay? Every integer is a rational and a real. So if we go up the hierarchy, everything below it is part of the category above. But not every real number has to be rational, because it could be irrational. So if I go down, it's not always true. So if you're ever asked a true-false question on a hierarchy, going up the hierarchy is true, going down the hierarchy could be true, could be false, right? Be a sometimes question that we might see in your homework. So let's continue with our rational. With the rational, then we'll come back to the irrational. We have integers. Integers, no fractions or decimals, right? This is where we have negative 1 and negative 1, 2 and negative 2. But 0 is part of that. So it's like 0, 1, negative 1, 2, negative 2. We're getting more restrictive. We're talking just our whole numbers. Whole numbers don't include any negatives, but they do include 0. So it says it is a subset of our integers. So it's the natural. And when you think of natural, that's your counting numbers. When you start counting, what do you start with? 1. So counting numbers. That's what natural numbers are. There's no 0. It's 1, 2, 3, 4, 5, 6, 7, 8. Keep going and going and going. Our counting. First ones you learn. So every natural is a whole number because we have all these counting numbers plus 0. Then we add the negatives. Then we add decimals that end or repeat, and all fractions. So if you see a fraction, the first thing you just want to go, rational. You don't have to, it's real and it's rational. The next category is that goes off of our real numbers is irrational. Last year you worked with this. I can't remember, it's right towards the beginning of the year that you guys did this. But when you did your square roots, you know, you had to memorize those squares and cubes kind of. You did that. Did you guys do that in pre-algebra some last year? Yeah. Square roots. Okay, so if you didn't, this is what we were talking about with our square roots. Irrational, the decimal never ends and never repeats. Like what? Like pi. Like square root 2. Like 0.141114, 1114. Someone says, yeah, but it repeats. No, it's a pattern, but it doesn't repeat, right? Because I have 1 and a 4, then I have 2 1s and a 4, I have 3 1s and a 4. There is a pattern, but it doesn't repeat, right? When we talk about a repeating decimal, that is like 7.21, where we get 21, 21, 21, 21 on our calculator. Okay. Questions? All right. So you are going to be asked to classify numbers. We're going to do some hands-on activities. I don't know if today, but probably Monday, where you're going to be looking at those. The next thing I'm going to be asking you to do is to add. And it says, when we add 2 rational numbers, there are a few patterns that are always true, so let's look at those. So, when you add 4 and 8, 4 plus 8 gives us 12. Is 12 rational? Could it be written as a fraction again? So we're looking at this, our first one that we were looking at here. Rational plus rational is always going to be rational. How about if I add 5 plus square root of 3? I'm not using my calculator. I have a rational and an irrational. Can I add those together to get something else? Like the decimal that doesn't repeat, it doesn't end? Because if you put square root of 3 in your calculator, it doesn't repeat and it doesn't end. It will end on your calculator, but it literally would keep going and going. Okay? So when we are looking at that case, if I add 2 rationals, it's going to be, in this case, rational. But if I add a rational and irrational, it is irrational. You can't actually combine those. This is simplified form of this equation, or this expression. So when I look at this expression and I say, add these 2 things together, that's simplest form. You can't combine anymore. It's like adding a calculator and a scissors, right? I can count how many calculators I have up here. I have 2 and I have a scissors. I do not have the superpower to morph these into cutting calculators, right? So we can't combine these things. That's what the kind of thing is. All right, so next if we multiply. What do you think is happening with the 2 rationals when we multiply? It's going to be rational, right? How about this one? What do you think it's going to look like? It is going to be irrational. So, like this is simplified form. Sometimes you might see this answer written like this, 9 square root 5. It's the same thing, right? There is a simple little multiplication right here in between. This is negative 12. Negative 12 is rational. It's an integer, to be more specific than rational, but it is a rational number. So it says these 4 situations are always true. Other combinations are not always true. And the question is, why is that? So, I want someone to give me a meaning if we are going to add a rational, let's go with an irrational and another irrational. So I want to give you an example of an irrational number that you're thinking of. Irrational. Square root what? Okay, square root of what? Square root 3, I agree, is irrational. So if I add square root 3, and I add another square root 3, how many square root 3s do I have? I have 2 of them. I have 2 square root 3s. Do you agree? Okay. This is irrational, right? So if I add these 2 irrationals, I get an irrational. Is it possible to get a rational number when I add? So could I take square root 3 and add something to it and get a rational number? Could I add something here and get it to equal a rational number, which is either a fraction, integer, whole number, all that lists under our categories? Can you think of anything? So what I want you to do right now, I want negative square root 3. What do I get? I'm going to add that and the negative. Here's a beautiful rational number. So when you add 2 irrationals, so when we look up here, right? So what they're going to want us to think about in this next page of our notes, if you have a rational plus a rational, it's always rational. Rational times is always rational. If you have rational and irrational, it will always be irrational. Same if you do the product, when you multiply a rational and irrational, will always be those cases are always the case. But when you work with 2 irrationals, it could be irrational and it could be rational. So on your next page of your notes, if you turn, that's one situation. So nice rational numbers that you're going to try and look at and think about are 0 and 1 is another beautiful rational number. Well, no, we'll just go 0. 1 is okay. The sum of 2 irrationals that can be rational. We just did that, right? It says, can the sum of 2 irrational numbers be rational? I want you to come up with a different example than what I put down, right? So we did square root 3 and negative square root 3. So if you're thinking of another number, square root what? That's irrational. Can't be 4, 9, 16, but something else. Square root of what? Square root of 5 is irrational, right? So we take square root 5, and we are going to add on negative square root 5. So it says, can the sum of an irrational number be rational? We would want to say, yes. Give an example. Square root 5 plus negative square root 5 is equal to 0. Now, could it be irrational? Definitely. If I added square root 5 plus square root 2, that's always going to be irrational. But the sum of 2 irrationals is good. So now we want to do the same thing, but now this time with the product. So this time I want you to be thinking of, oh, I need to multiply 2 things together that are irrational. And I need it to become a rational. Is that possible? If you think you got one, check with the person next to you or behind you, in front of you, and then let me know.
Got one?
Anyone have anything that they can think that when you take these 2 irrationals and you multiply, that I get a rational number? Okay? Square root 2. and multiply it by to get a fraction. What if I take it times itself? What's the square root of 2 times the square root of 2? The square root of 4, which is equal to 2. So if you multiply 2 irrational, square root of 2 times square root of 2, you're multiplying. The rules of multiplication say multiply the same thing underneath. So this is like saying the square root of 2 times 2. Starting with 2 irrationals, we got square root of 4, which equals 2. Do you agree that that is? So could you come up with at least 2 or 3 more examples in that section? Yeah. Do so. Write 2 or 3 more other than mine. Other than the square root of 2. Now, definitely, you could have had where it's going to always be irrational. And it's if I have something like square root 4 times square root 3. No, square root 4 is not irrational, right? So square root 2 times square root 3, that is going to be square root 6, and this is irrational. But if I asked you to come up with some more that were rational, okay? So, give me another example in the back, right here. What do you have? Because I don't have your name, so I'm looking at these.
I don't have one.
Okay, come up with one. You have to come up with one. Someone have do you have one?
Yeah.
Okay, give it to us.
Square root 5 times square root 5.
Square root 5 times square root 5. I agree. That is going to be equal to just 5, right? Square root of 25 is 5. Did you get one yet?
No,
Now pi, it doesn't work. Pi does work up here for the addition part, right? Because if I add pi plus negative pi, even though it never ends and continues, right? If I add the two opposites, I'm going to get 0. All right. What'd you have? Decide. You got to come up with one. You two are both, you're my 2 people today. Did you get one? Pick a number that's not a perfect square.
7.
Okay, square root 7. So if I take square root 7 times square root 7, I get square root of 49, which is 7. Another example where this is rational, right? Do you have one? 9 is a perfect square. 9 is not irrational, right? Is 10? Is 10 a perfect square? The square root of 10, can you go, oh, the exact same number times this is 10? Is 10 a perfect square? No. So we can use 10. We can't use 9. Does that make sense? That's why when I put 4 here, I said, oh, I can't use 4 because 4 is irrational, right? So if I have square root 10 times square root 10, that is going to equal 10. Okay? So hopefully you can come up with more of those. These two are kind of important, like, hey, you're going to probably see this on a quiz or a test. I'm going to ask you to give me an example of 2 irrationals that can make irrational when you add them and when you multiply. You will see that on a quiz or a test. You will see this, and I'll say, if it doesn't work, and so when you go, oh, I just can't think of something, make sure you look at this part of your notes, okay? So, in summary, what do we know? In summary, what do we know? We know that, and again, my writing sometimes isn't the best, so sometimes I like to use this. We have 4 types of problems that we looked at that are always true. So when you go back, the rational plus irrational, that product and multiplying those first 4 types, those are always true. But all combinations of operations that are either from then on are either going to be a sometimes true or they're never true. They will either never, any other combination besides those 4. Those 4, they hold the test. They are always going to be that way. And I'll always try and give you enough time, so sometimes I'll just like ask for like a thumbs up when you're done copying or when you got everything written down. So if you would, just in front of you so that I know you're done writing. And a lot of times I can kind of see, but sometimes people are doing other things, so I have an idea. When you come in Monday, you have a question on something. You're not sure about questions 7 and 21 or something. When you walk in the door, you can just write them up here. You can always raise your hand when I ask for questions before we take a homework quiz. We'll probably have a homework quiz Monday, just on what you did today, like on doing this kind of stuff and classifying them and doing some stuff. It'll be a smaller quiz. When I do my homework quizzes, I usually grade them on a 4, 3, 2, or 1. 4 meaning, you know what, you got this. You pretty much understood it. You could teach it to a friend if I needed you to. You understand everything I asked. You pretty much got everything right. A 3 would be, I can do it, but I make some mistakes. A 2 would be, I sometimes do it, but I usually need some help, partially proficient. And a 1 is, I can't really do this, it looks like, and a 0 would be like you didn't even attempt the quiz, right? And I'll talk more about those next week when we start those. So, as you look here, notice it says your answer, you are going to answer rational or irrational. I do not want you to find the solutions. It's on that top of that next page. You're not going to tell me what 1/2 plus 1/3 is. What I want to know is that answer rational or is it irrational? And I believe that when you are doing this, you could use R for rational and just put an I for your irrational. So what I would like you to do is right now in those boxes, going down, something irrational. If we are looking at, hey, you ready? Negative square root of 2, positive square root of 2. What would you say? It is going to be rational. Right? Should have an I. If I add 6 plus the 3/4, if I'm looking at that one, it's going to be rational too, right? We start with 2 rationals, we're going to end with 2 rationals. Square root 8 and square root 9. Square root 8 is irrational. Square root is irrational. Square root 9 is a rational number, right? So if I'm looking at that one, Angus.
Irrational.
Should have irrational. Square root 4 times 3. What kind of numbers are we talking about? They're both what? They're both rational, right? Square root of 4 is 2. That's rational. So this should be definitely a rational. If you're not sure about the square roots that are irrational, if you know your perfect squares, 1, 4, 9, 16, 25, 36, all of those are going to be rational. So the square root of 4, square root of 16, square root of 64, those are all rational. If it is not a perfect square, it's irrational. The square root of that. Okay? So I have 1/2 times 7.5. I should be looking at it being rational. Square root of 3 times square root of 7. I get square root of 21. Square root of 21 is 21 a perfect square? 25 is, 16 is, not 21. Irrational. Okay? And you are, actually, when you multiply these, this does come out to be the square root of 21. But that is still irrational because it's not a perfect square. Okay? If we are looking at the last two, pi times -2 should be irrational. Last one, rational or irrational? Rational. Should be rational. Square root of 16, right? Alright. So, some of what you're going to be asked to do in your homework is just tell me when you add or subtract this, is it rational or irrational? Some of what you're going to be asked to do in your homework is going to say, oh, classify them in these categories. So, what I want you to do right now, you can see if you get the joke of cloud now that I kind of talked about. So pi, to get real, we talked about imaginary numbers, right? Not real. There's some people that I know, some of my math friends in college, and that are teachers, and they'd be on teams, and they'd have that as part of the, one person was be real, and the other one was be rational. Some of us math kind of people anyway. So I want you to list 3 types of numbers in each of the categories here. Okay? So if you need to look back at that initial list of what a whole number is, then it says an integer that is not a whole number, a rational that is not an integer, and then irrational. So I want you to just take a few minutes